Hey everybody, welcome back to the NLP for Tensorflow tutorial series. In the last video, what we did is we created a LSTM model for sentiment analysis, but we never ran it. So that's what we're going to try to do today. So let's get right into it. We're back inside our model function, and the first thing we're going to want to do is we're going to add an equal sign here next to the shape because that was typo. It's my bad. And then we're going to scroll down, and we're going to go underneath this prediction here. We're going to add a couple tools to help interpret our results of our model. Because this prediction, what we're doing is we're creating a prediction to compare to the labels that we gave it. So is a sentence positive or is it negative? And our prediction should hopefully correspond with that. But all we do really is calculate a one number, right, our loss over that entire batch. What we really want to be able to do is say, for each sentence, what was your prediction for that sentence? And that way, once our model's trained, we can actually use it. So let's go ahead and do that. We're going to go underneath this prediction, and we're going to add a few lines of code. So first, we're going to say correct prediction equals tf.equal the tf.argmax tf.nn.sigmoid of our prediction, axis equals 1, and the tf.argmax of our y, and the axis is also going to be 1 because those are multi-dimensional arrays, so that's why you have to do that. And yep, that's all set. So basically what this line of code is going to be doing is, I'm not sure if you were able to see that before, but what this line of code is going to be doing is it's going to be comparing this, which is our argmax of our predictions and the argmax of our labels, and basically saying, are they equal? So to be more clear, our predictions and our labels, they might look like this. I'll show you. It might be 1, 0, 0, 1 for the labels. Those are the true labels. And this might be 1, 1, 0, 0. And basically our correct prediction should look like this. So wherever they're equal, so if this 1 and this 1 are both equal, right? They are. That should be a 1. The next one is going to be a 0 because they're not the same. The third one should also be a 1. And the fourth one should be a 0 because these ones were both correct and these ones were both incorrect. So that's what our correct prediction is going to be doing. And then what we're going to do is, for over this correct prediction, we want to know what the accuracy is over the entire batch. So the loss is kind of a metric that lets you know how much to tax the model, but it doesn't actually tell you how accurate your model is. So what we're going to be able to do is we're going to take this and then just create a mean over it, right? Because yes, this is right. No, this is incorrect. This is right and this is incorrect. What we want to do is say our model is 50% accurate based off of this array, right? So let's take that 1, that 0, and that 0 and create a mean out of it. And to do that, what we're going to do is do a reduce mean. So we're going to say our accuracy equals tf.reduce mean. And another thing to think about is these are all integers. So in order to do a mean, we're going to have to cast this correct prediction into a float. So we're going to say tf.cast correct prediction into a tf.float 32. And so we're doing the reduce mean over the float version of this. So that'll give us our accuracy. And next, we're gonna make a tensor that will tell us what the choice was that we made for our prediction. Because this is really just telling us which ones we got right or wrong. It didn't really tell us what our choice was. So we're gonna also calculate this. So choice our model made. I'm gonna say choice equals tf.argmax. And it actually should just be the same thing as this, right? tf.argmax, yeah, it should be this. Beautiful. Okay, so now that we've done that, we're gonna modify our return statement to include these extra variables. And it looks like I already did that, so we're just going to leave that there, but now the new return statement is going to be optimizer, loss, x, y, accuracy, prediction, correct prediction, and then choice. Okay, so now what we're going to go ahead and do is we're going to initialize our batch size. So we're just going to set that, and also our number of epochs. Epochs equals 5, we'll say. And then we're going to split our data, which we created previously, right? So it's up here, our data and our labels. And we're going to go ahead and use the scikit-learn train test split method to split those into our training and testing sets. So x train, test x, y train, test y equals train test split. We're going to have to pass our data and our labels. And our test size equals 0.3. And our random state is going to be 42. All right. So after that, we're going to go ahead and we're going to build our graph and get all these returned to us. So in order to do that, we're going to say optimizer, loss, x, y, accuracy, pred, correct, pred, and choice equals model. And then we're going to be able to start our session. So with tf.session as sesh, we're going to say init equals tf.group, and I don't really know why I did it this way, but I have two initializers. I think there's some sort of reason, but I couldn't tell you. Initializer, can't talk and program at the same time. tf.local variables. So global variables initializer and a local variables initializer, and that's just a group. And so basically, if you say sesh.run the init now, it's going to run both of these. Perfect. And now we're going to create a saver and a writer so that we can save our weights. So saver equals tf.train.saver. And the same thing with the writer equals tf.summary.filewriter. And we're going to have to pass this our log directory, we can see, and our graph. So logdir, and then our graph is going to equal our sesh.graph. And then we can start iterating through our epochs and passing our data. So for epoch, in range of our num epochs, we're going to say, well, we're going to print that what epoch we're at. So we'll say print epoch plus 1 out of num epochs. And then we'll just close that out. And now we're going to say if the epoch is not the first epoch, we're going to want to shuffle our data because we don't want to feed it in the same order every time. So if epoch is greater than or equal to or greater than 0, we're going to say data equals list zip x train y train. And then we're going to go ahead and say shuffle data. And then we're going to go ahead and unpack what we just shuffled. So train y train equals zip and then star data. I think that's right. Yep. Okay. And now we're going to say for I in range of our num batches. So for every batch that we have, oh, we didn't create this variable. Okay. So we're going to go back up here and we'll say num batches equals length of our x train divided by batch size. And if you do it with the double slash, it'll give us the number without the remainder. And basically for the remaining samples, we're just going to pass a variable length batch depending on however many samples are remaining. All right. So now we have that number. So for I in range num batches, we're going to say if I does not equal range num batches minus 1. Oh, not range num batches, just num batches minus 1. So if it's not the last that last bit of remaining data, we're going to pass it a batch size length batch. So we'll say x batch equals x train I times batch size. And we'll do that 2I times batch size plus batch size. And we're going to do the same thing with the y batch. We're going to go ahead and copy this because it's the same thing. And now we're going to say else. We're going to pass it whatever the remaining number of samples is. So x batch equals x train, and it's just going to be I times batch size until the end of the array. And we'll do the same thing with the y batch again. We'll just copy this and make sure you guys can see this. And then what we're going to do is be able to actually run it. So underscore LA equals sesh.run. And our fetches are going to be our optimizer, our loss, and our accuracy. And then our feed dict is going to be x and x batch, y batch, and that's it. Okay, so now it's going to run, but we're going to want to go ahead and evaluate at some point. So if I is greater than 0 and I is divisible by 100, we're going to go ahead and print the step that we're at out of the number of batches. And we're going to go ahead and print the loss, which should probably really be a moving average if you think about it, but we'll leave it like this for now. And then we'll do the same thing for saving the model, but we'll do that a little less often. We'll do that, how about every 500? And we're going to do saver.save our session. You have to pass it the logdir again. And we're going to call this LSTM model.ckpt. And that should be good. And then we say writer.flush, writer.close. And we're also going to take this, and if we're on our last epoch and we haven't saved yet or something, or we want to save the very last second, we can go ahead and paste this. I'll do it there. Okay, so that way we're saving as well at the end of every epoch. And there you go. Now our model's going to run. So moment of truth, we'll see if it works. All right, so it looks like our model's running, but you can see that we're not getting very far because we have a data constraint. If you remember correctly, we did that here. So we can just get rid of that, delete this later. We'll go ahead and just delete it. And now we're going to run it again, and we'll see if that works. All right, so as you can see, I waited for our model to run, and we got to epoch 5 out of 5, and by the time we got done, our accuracy was in the 90s, so that's pretty high. So we did great. And in the next video, what we're going to try to do is use those few things that we added to the model this time to help interpret our model, and also to help use it for actually predicting sentiment of a given piece of text. So thanks again for watching, and if you have any questions, leave them in the comments. I'll see you next time. Thank you. Bye-bye.